presentation. I'm Haytham Afli from Lyon Laboratory in France. So today I will present our work in extracting parallel corpora from multimodal comparable corpus, and especially our method for parallel phrases extraction. So during this presentation, I will begin by an introduction and the context of this work and the existing method in this domain. Then I will present our system extraction, some experiment and results. I will finish by conclusion and discussion. So statistical machine translation is the context of this work. As we know, the purpose is to translate text from source language to a target language using this equation, which modeled by translation model, language model, and a decoding algorithm. Actually, there is some tools, existing tools like Moses and Joshua, which develop this method, but still we have a problem of parallel data, which is represent texts that are translation of each other, and an essential resource for machine translation and other NLP application, because they provide training data for translation models, but the problem is they are expensive and time consuming to prepare in order to translate and to prepare the sentence alignment, and they are also limited in size language, and domain. One way to overcome this lack of parallel data is to exploit comparable corpora, which is generally not parallel but contain the same information, and they are more readily available than parallel data in terms of quantity, language, and gems. Mainly they are available from Newswire like FP Al Jazeera, and also we have a large collection available for NLP tasks like Gigawatt Corpora from LDC. So the existing method to exploit this comparable corpora aims to extract parallel documents using certain information or parallel sentence alignment algorithm, in order to extract parallel sentence or phrases. We have here in this domain four main methods. The first one is the web crawling, in which Resnick and Smith use URLs to find matching documents. The second one is the alignment proposed on sentence level by Brown and his colleague IBM, and in phrases level by Quick and his colleague, in which they used word alignment model to judge how to close the source and target. The third one is the cross-language information tree proposed on sentence level and phrases level into by Matthew, and the fourth one is the translation method, in which we use Abdurrauf and Mike use SNT system to translate a document. What we propose here in our work is to extend this existing method in order to exploit multimodal comparable corpora to extract parallel texts or parallel data from a corpus composed by an audio in one side and a text in another side, and which contain the same information. So our proposed method composed by five main steps. The first one, we begin by building a baseline SNT system using generic data. We transcribe this the audio. We transcribe the audio side here by an ASR module. Then we use this, and then we translate this transcription, this text, transcribe it using our SMT baseline system. Then after that, we use this translation as a query for the information retrieval module to find the matching sentence or phrases in the target comparable corpus. And finally, we filter the results provided by the ER module using machine translation metric called TR. So in this work we applied two methods. The first one is to extract phrases, parallel sentence data, in which we call it sentence extract, and the second one is to extract parallel phrases data. So the difference between these two methods we can see here in this we can see it here in this figure is mainly in this model for the first side where we split the sentence transcribed by the ISR, the speech recognition system, on phrases and translate it and continue the same framework. And here also for the text, the second side of the corpus, we split the sentence on the sentences on this text on phrases, and in order to get phrases as a result of query. So this method raises several issues, mainly in two questions. The first one is about the quality of the corpus. A question here is that can we get a parallel data generated from this multimodal comparable corpora, good as BDX generated as other methods applied on comparable text. And the second one, and which is important on our context, is about the effectiveness of this method. The question is that this extracted by text, can we get a quality of bytext that can improve our SMT system and performance in order to adapt it for a domain. So in order to answer this question, we did some experiment on TED data, which is composed by talks in English, which represent the audio side of our corpus, and the text written in English, which represent the text side of our multimodal corpus. So we applied our two methods on this data, sentence extraction method, in order to detect all parallel phrases from this data, and phrases extract in order to detect or phrases, parallel phrases. We evaluate our approach using re-injection of generation of this extracted data on the baseline system, and evaluate it using blue score. So on this experiment, as we said, we use for training generic data composed by use commentary and Europar, and for extraction TED data, which is split for phrase extraction. The main model which we use it on this system architecture is composed by three systems. The first one, the speech recognition system, which based on same use facts, which has a word error rate of about 18%. The second one is SMT based on Moses Toolkit and Giza++, tuned with MERP. The third system is an information retrieval system based on Linear Toolkit, in which we index all target branch text data and transform the translated source language translated, which is transcribed by the answer system to query used in the query language. So as a result, we have here a table of result with two different methods. As we said, we use TR to filter all results. So that's why we have different corpus with different TR threshold. Here we can see in this table we have the best performance. We have it on phrase extraction, but still the sentence extraction improve also our baseline system, and other result is about the appropriate threshold for each appropriate threshold for each method. We can see here, for example, here the phrase method, and this is the sentence method, and this represents our baseline. We can see for example, for phrase extraction, the best one is 60, and for the sentence method, the best one is about 80. Yeah. That's why we applied combination of these two methods, and the result is that this is the combination, the graph of the combination. The result of the combination is quite the same thing like the phrase method. We have here some example of improvement of domain adaptation and oral vocabulary correction. For example, first example, our baseline system translate food as a nourriture in French, and we have with our adaptation we have correction of this translation at produit alimentaire. It's the best translation. The same thing on this second example. So we came to the conclusion. We presented here, we proposed here in this work an extension of exploiting comparable corpora to multimodal comparable corpora, in which we used an audio in source side and a text on the target side. Our experiment in this corpora present an encouraging result, since we are automatically aligned align source audio in one language with texts in other language without the need of human intervention to transcribe and translate data. Also, we presented here methodology, which is the first effort to detect translated phrases on multimodal corpora, and our results, our experiment shows that we can adapt a generic SMT system using for a domain like lecture, for example, in TED, using multimodal comparable corpus. So our perspective about this work is to apply this task or this method as much larger scale, using hundreds of hours and of speech and hundreds of millions of words. We want to work on different specific domain or subdomains. We have other extension, for example, iterate the process in order to use extraction by text to translate again source sentence, and calculate the degree of the similarity of corpus before using it. And that's all. Thank you for your listening. So, any questions?
questions. I noticed that your system is quite similar to Adobe Rough 2011 system.
Wait, similar to?
Your system is quite similar to the system proposed by Adobe Rough. I don't know the pronunciation is quite right or not. Adobe Rough 2011. You referred this paper again. And the only difference is that you split a sentence into phrases before translation, right? In your system.
I really imagine.
So
You want the architecture of the system?
yeah. So the only difference is that you split sentence.
The extension. Yes, the extension here is we have a system for phrases. It was for sentence extraction. It was the first system used, in my knowledge, used for multimodal comparable corpora, and we extend it for phrases. The idea for phrases is to split our sentence on groups of words. In order to get this segment and to search for the corresponding segment on the text side, the text of language side of the corpus.
So I'm wondering, your split method, you just consider all the combination of phrases?
We consider a combination of yes,
2 to 10.
Yes, we split our sentence from 2 to 10 phrases, words. On phrases composed by 2 to 10, maximum 10 words.
Okay, and the second question is that there are also other studies, for example, Mutani 2006. They also try to extract pair fragments or pair phrases from comparable corpora. But you try to compare your.
But they use it only for text. We cannot compare different corpus. We use it for this work is used for multimodal corpus which composed by audio and text, and this work is or previous work it's doing for text corpus. So we cannot compare, but the evaluation we did the evaluation in order to add this in adding this extracted corpus in the SNT baseline and evaluate it.
I'm just wondering how that Mutani, for example, Mutani 2006 method how will it perform on your data? So if you give a comparison, it will then.
Which one? The cross-language information?
Yes. Mutani 2006.
2006. Mantino
Yes.
Marcu
use something like that. So there's several previous works that you can compare your approach
to compare these two methods. For example, I don't know about for Mantino and Marcu, they use their method on sentence level in 2005 and phrase level in 2006.
Yeah.
They use, as I mentioned, lexicon to translate source word and apply information retrieval. The difference between us is that we use the difference is for the application of extraction on multimodal comparable, and the second one is we use an SMT system in the place of the lexicon.
But your system is similar to another ritual. Could you go back to this?
Apply context.
Yeah.
Similar.
Rated. The last
translation. Yes.
It's quite similar, right?
Yeah. Similar to this. Yeah.
Okay, so the time is up. So let's thanks to the speaker again.
Okay.
Okay, so the next one is a very last presentation.